Ever struggled with actually running the tool calls your AI generates in dspy? We'll walk through the exact code to execute those calls 4 different ways: letting dspy automatically find your functions, passing them explicitly as a dictionary or tool objects, and even the manual lookup method for older versions. Each approach takes the same tool call, runs it, and shows the result. Hash after getting a response with tool calls. For call and response outputs tool calls. Print f tool name, call name. Print f arguments, call args. Hash execute individual tool calls with different options. Hash option 1, automatic discovery, finds functions in locals globals. Result equals call execute. Hash automatically finds functions by name. Hash option 2, pass tools as a dict, most explicit. Result equals call, execute functions equals weather. Weather calculator, calculator. Hash option 3, pass tool objects as a list. Result equals call, execute functions equals dspy. Tool weather dspy tool calculator. Hash option 4, for versions earlier than 304b2, manual tool lookup. Hash tools dict equals weather, weather calculator, calculator. Hash result equals tools dict call name. Print f result, result. This demonstrates the tool execution resolution pattern in dspy, where a tool call object provides multiple explicit ways to locate and invoke functions. The code shows 4 concrete resolution strategies: automatic name-based discovery from the current scope, explicit dictionary mapping of function, names to implementations, execution via dspy tool objects, and the legacy manual lookup approach for pre-304b2 versions. The pattern works by centralizing function resolution logic within the execute method while exposing different lookup mechanisms through method parameters. Each approach maintains identical execution syntax, call execute, but differs only in how the target function is specified, either implicitly through scope inspection or explicitly through past mappings. This creates a uniform interface where the resolution strategy becomes a configuration detail rather than a code structure chain. This approach matters because it gives developers direct control over function resolution without altering the execution flow. The explicit options, dictionary, and tool object lists make dependencies visible at call time, while automatic discovery reduces boilerplate for simple cases. The inclusion of the legacy manual approach also ensures backward compatibility, allowing the same execution pattern to work across dspy versions. Let's break it down. For call and response outputs tool calls. Print f tool name, call name. Iterates over each tool call in the AI's response output. The call name accessor extracts the specific tool being requested, which is essential for routing and execution. Result equals call execute. Hash automatically finds functions by name. This invokes the tool call with automatic function discovery. It searches the current scope for a function matching the tool's name and executes it with the provided arguments, handling the simplest case where tools are already in scope. Hash option 2, pass tools as a dict, most explicit. Result equals call, execute functions equals weather. Weather calculator, calculator. This explicitly maps tool names to their handler functions in a dictionary. It eliminates runtime discovery by directly specifying which function executes for each tool call. Hash option 3, pass tool objects as a list. Result equals call, execute functions equals dspy, tool weather dspy tool calculator. This passes tool functions explicitly wrapped in dspy, tool, objects as a list to execute. The pattern provides direct control over tool instantiation while maintaining the same execution interface as other options. Print f result, result. outputs the tool's execution result for inspection. This simple print statement serves as verification that the tool call completed and returned data. dspy.Tool call execution. This snippet demonstrates 4 distinct ways to execute tool calls, from automatic function discovery to explicit tool mapping. Option 1's call execute silently fails if the function isn't in scope, while options 2 and 3 require explicit tool registration. The legacy option 4 shows the manual dictionary lookup pattern used before version 3.0 for B2.
The call that executes without a function finds all functions